So alkane, what will be molecular formula for alkane? CnH2n+2. Alkane are aliphatic hydrocarbons, so it means hydrocarbons that are not aromatic. They only have hydrogens and carbons and the sigma bonds only. All single bonds are sigma bonds. The simplest one, methane, not methane, but methane. The simplest one you can find where? Natural gas. And there are all other sources of alkane. And the alkane can be straight chain, like balls, or they can be in a ring. If you have in a ring, then molecular formula will be 2NH2N, because you have to remove 2 hydrogen to connect them. So now let's look at the propane. 3 carbons alkane. We can have a different representation of alkanes. This is condensed structure. This is Lewis structure. And this is 3D representation of propane. That's a model. So which of this is not propane on this page? The last one. So the point is, for the line structure of, doesn't matter if we have 1, 2, 3 like this or like that. It's just however you hold in this. It's the same. But here this is different because different number of carbons. This actually will be what kind of? It has a 4 carbon, but the name will not be butane because it's branch, and we'll get to this. So now, if you have a 4 carbons, if you have a 3 carbons, look at this. I cannot, how many structural isomers I can make with 3 carbons? No, there's no way. I cannot have other arrangement of atoms. So, because if I will take this, put here, it's the same. So that's why we have only propane. If I have a 4 carbons, this will be, what's the name of this one? 4 carbons alkane, butane. But I can take this carbon and put it on second, attached to not to this one, but to next carbon. And now this is not butane anymore. This is isomer of butane, because this will have a different properties than the previous one. So we will not call this butane anymore, because when you say name, the name should be just for specific structure, one structure. Each structure can have more names, because there is common names, there are systematic names, they are, like if you have a drug, you have generic names, all different names can have. But if you have a one name, the name has to be for the specific structure. If you say me this name, I will know how to draw the structure. So this, we cannot call this butane anymore. So we will call this isobutane, because that's an isomer of butane. Is there any way we can make another isomer? No, because if I will put here, that it was the same if I have here. Is it? Yes?
I was saying 2-methylpropane isobutane will be the same.
That's right. Yeah, I just don't want to introduce it yet, but that's right. You already know. Some of you will know the naming, I know. So this will be, that's right. So this will be butane, this will be isobutane, other name 2-methylpropane, you're right. So they are not the same, they are different. They are constitutional isomer, they have the same molecular formula. Now, if you have a 5, if you have a 5, if you have a 5 carbons, then how many different constitutional isomer I can have with the 5 carbon? Let's draw all of them. So I can have for sure this one, and this one will be line structure 1, 2, 3, 4, 5. So this name of this will be pentane. But how else I can arrange this atom? I can take this carbon, put over there. This will be different, not the same. So line structure for this will be 1, 2, 3, 4, and the 5th one going here. What about if I have something like that? One, 2, 3, 4, 5. Is this the same or different? This or that? Are they the same or they are different?
The same.
They are exactly the same. So just, I was telling you how you know that they are exactly the same. They will have the same name. Because 1, 2, 3, 4, I will count from this side. 1, 2, 3, 4. So it doesn't matter how in space I will have, name them. If they have the same name, they are the same compound. So they are the same. I just wanted to, so you will see different way of this. So this is the same. Can I make another one with, what's about if I will take maybe this one and put over there? This is different. So this will be like that, or if I will show like this, doesn't matter. That's the same. This is the same. 1, 2, 3, 4, 5 carbons. So that's different. So how we have to name them differently because they are not the same. Today I wanted to concentrate on this very common naming of the groups, like this is pentane, some of this have to be isopentane, but they both cannot be iso because they have to have their own special name. So this will be iso. Always, if there is kind of branch like this at the end, it's iso. So if I will have, for example, the compound like this, 1, 2, 3, 4, 5, 6. What's the name of this? That's how many carbons total I have? 6, but that's not hexane. This will be isohexane. This ending branch at the end, iso. Okay, so we know that's a pentane, this will be iso, so this we'll have to call differently. So we'll call neopentane. So first one is pentane, then isopentane, and then we'll call neopentane. Okay, and the more times we have, the higher number of different constitutional isomers we can make. You should memorize this. I don't like memorization, but this you have to. This, if you don't remember, you have to memorize first 10. The last one not. First 10, you have to know this by heart, first 10. Please, if you don't know, some of you already know, I know. But if you don't, memorize. And those are easy to memorize if you like in this order. Are you learning in the same order, like methane, ethane, propane, butane, and so you're like, so then even if you don't remember looking 6 carbon, so you repeat your methane, ethane, and see which carbon it is. How you memorize this? That's this way, in an order? Yeah. So if you don't, memorize this, if you don't know already. Now then, classification of carbons. This carbon we call primary carbon. So here, this is primary carbon, using this as a primary carbon. So primary carbon is attached to one other carbon. This one is secondary carbon. So here I have secondary carbon. Secondary carbon is attached to 2 other carbons. So this will be what kind of carbon? Primary, this primary, and this is primary. And this carbon will be tertiary because it's attached to 3 other carbons. So here we have tertiary carbon because this carbon is attached to 1, 2, 3 other carbons. So that's tertiary carbon. And this carbon will be quaternary carbon because it's attached to, I'm not checking notes today, I will check on Monday. So that's quaternary carbon attached to 4 other carbons. Now hydrogen. This hydrogen we will call primary hydrogen because it's attached to primary carbon. So, and this hydrogen will be, tell me, secondary hydrogen because it's attached to secondary carbon. This is primary, primary, primary. This hydrogen is tertiary because it's attached to tertiary carbon. And those are primary, all of those hydrogens are primary hydrogens because they are attached to primary carbon. And we don't have hydrogen attached to quaternary carbon. So are you okay with this? Primary, secondary, tertiary, quaternary, depending to how carbons, depending to how many other carbons is attached, and hydrogens depending to what type of carbon it is attached. Cycloalkanes, we already said that you have to remove 2 hydrogens to make a ring. And how many carbons do we have? 1, 2, 3, so it's propane, but because it's in a ring, we put cyclo in front. We have 4 carbons, so it's butane, but put cyclo in front. And so here we have 6 carbons, but it's in a ring, so we put cyclo. Assuming that we have a strong chain or long chain of carbons. And we have if I will have a hydrogen here, what's the name of the alkane with 1 carbon? Methane. So this is methane. But if I remove a hydrogen and put this group on a long chain, this is not methane anymore. This we will call, we just have, this we will call a group. So that's an alkyl group. The same if we have, we call methyl bromide. It's not methane anymore. So we can remove hydrogen for any of this alkane and attach them to long chain of carbons. And we will have to know how to name this group of carbons. So if I will take, what's the name of this group?
Ethyl.
Yes. So you don't count this carbon because this carbon belongs to long chain. So I have 1, 2. I have 2 carbons. So this will be 2 carbons, F, and then I will add Y, L. Now, if I have 3 carbons, if I have a 3 carbons, how I can attach 3 carbons on a long chain? I have 2 types of hydrogen here, primary and secondary hydrogens. I can remove any of the primary hydrogen and attach to the ring like that, or to the long chain like that. So 1, 2, 3. And I have 1, 2, 3. How I will call this group? Because 3 carbons. But I also, there's other way to attach this. I can remove secondary hydrogen and attach like that. This is not the same, so I cannot call it the same. So I can attach like that. This would be 1, 2, 3, also 3 carbons, but attached differently. And I cannot call the same. So how I will call this, like this one, when I remove secondary hydrogen, I will call this iso. Now, if I have 4 carbons, how many different ways I can attach 4 carbons? So 4 carbons, I can have, oops. Okay, I can start from butane. And how many different types of hydrogen I have? How many different types of hydrogen do I have? 2. Primary, let me see, 1. Borrow hydrogen. So primary and secondary. If I remove any of primary hydrogen, I can attach like this. One, 2, 3, 4. And I will call this but group. But I can attach this if I remove secondary hydrogen. So then it will look like that. 1, 2, 3, 4. And this I will call
Sec.
sec, because attached by secondary carbon. So this will be sec. But I can have 4 hydrogen like that, starting from this isobutane. And here I have primary hydrogen and tertiary hydrogen. So if I remove any of the primary hydrogen and attach this on the ring or long chain, I will have something like that. This will be 1, 2, 3, 4. And how I call this? I will call this isobutyl, because notice has this ending at the end. Even on a chain, if I have something like this, 1, 2, 3, 4, 5, 6. What's the name of this group? Iso. Differentiate from the same chain. So this will be iso. But this will be isobutyl. But I can also remove tertiary hydrogen and attach like that. If I attach like that, I will call this third butyl, because will be attached by tertiary carbon. So this will be 1, 2, 3, 4. 4 carbons in a group. And we will call this third or T butyl. So now let's look at this example. What kind of group do you see attached to the longest chain? What's the name of this?
I see isopropyl and sec.
On the bottom,
Yeah.
1, 2, 3 carbons. So this will be, but they are not attached by primary carbon. So that's isopropyl. And the top one, 1, 2, 3, 4 carbons. So
Sec.
sec, because attached by secondary carbon. Very good. Okay, so how we will name the organic compounds? First of all, find the longest chain of carbons. At the end, functional group. For alkane, this will be at the end A and E, because it's alkane. Then we will have different compounds, alcohol and others, and we will put different ends. Right now we have A and E at the end. And in the front, we will put name of these substituents. These groups are substituents, and the location of these substituents. So just review. First thing we should do to name, to find the longest chain. Continuous chain of carbons. So here will be 1, 2, 3, 8. And here we have 7, so the correct will be 8 because it's more. And we have to remember that sometimes the longest chain is not in one lane, but can be bent. You have to just try and see this way, this another way. You have to try and see which way will be the longest. Continuous chain of carbons. What if you have the two chain with the same number of carbons? The chain that both ways, this way and the other way, you have the same number of carbon. But then which one you choose as a parent chain? The one with the more substituents. So this one, because there are groups attached to this one. To this, only one group is attached. So you will choose the other way, with more groups attached. So the first thing will be to find the longest chain, then number the carbon from the end to give the first substituent the lower number. So 1, 2, from this end, 1, 2, 3. So this will be the first one, because that's from the other end. If the first substituents are the same distance from each end, here you have 1, 2, here you have 1, 2, then number from the end to give the second substituent lower number, and if the second the same distance from both ends, next substituent, and so on until the point of difference. So you don't look at the total number of substituents, but next. If from both ends, 1, 2, 3, 4, 5, and from this end, 1, 2, 3, 4, 5, for both ends, the same distance, all the substituents. Then choose the end using the alphabetical order of this group. So like this group starts from E and this from M. So you start numbering from this end to give the lowest number to the substituent that comes first in alphabetical order. So name and number substituent to which each substituent to which carbon is attached, name substituents. So remember that each carbon belongs to long chain or substituent. You cannot count twice. And each substituents have to have their own number. If you have the same substituent repeating like this and this, 1 carbon and 1 carbon, you will use di. Or if you have 3 repeating, you use tri, or 4 tetra. In alphabetical order, remember the di, tri does not count. The sec, ter does not count. Only iso and neo and cyclo counts in alphabetical order of substituents when you look at the substituent name. And then combine of these parts, put the substituents in alphabetical order. So iso will count in alphabetical order, but di, no. Dibutyl, when you look at P, you will, each substituent should have a location on number of a carbon to which it's located at which one. Separate numbers with commas, separate numbers from letter by hyphens. No space between the name of the substituent and the parent name. So here we have location of 2 carbons located at carbon 5. 1 carbon substituent, and we have 2 of them. One is located at carbon 2, another at carbon 6, and that's a parent name. Okay, now group work.